BIM is a process where we use intelligent 3D model. For example, I hope most of you have used AutoCAD in your college days or in your work life, you might have used AutoCAD, right? For example, let's say if you have to create a wall in AutoCAD, what will you do? You will draw a rectangle first, and then you will do extrusion, and then you can create a AutoCAD 3D wall in AutoCAD, right? If you select that particular wall in AutoCAD, will it give you any information? If you select that particular wall, you will be able to know, you can measure the dimension of the wall, and you will also know the layer properties. Apart from that, you will not know a lot, you will not get a lot of information from an AutoCAD 3D model. So an AutoCAD 3D model is not an intelligent 3D model. Similarly, SketchUp. SketchUp is a software majorly used by architects for creating concept designs. That is also not an intelligent 3D model. These software are used majorly for visualization. But in BIM, we use intelligent 3D model. It means, for example, let's say Revit. Okay. In Revit, if you select a wall, okay, it will give you a lot of information about that particular wall. If you select a wall, you will know how many layers are present inside that wall. Okay, what are the thermal properties of the wall? What are the material properties of that wall? A model will give you a lot of information. Okay, so that is an intelligent 3D model. So BIM is a process where we use intelligent 3D model used majorly by AEC professionals, architects, engineers, and construction professionals, so that they can efficiently plan, design, construct, and manage buildings. Okay, so it is used in all the stages of a project, from initial planning to managing of a building. Okay, BIM is used in all the stages of a project. Okay, so this is the actual definition for BIM. BIM is a 3D intelligent 3D model based process that gives AEC professionals the insight and tools to efficiently plan, design, construct, and manage buildings and infrastructure. Okay, so let me put this. Okay, okay, and move. So there are different levels in BIM. Okay, starting with level 0 of BIM. Level 0, level 1, level 2, and level 3 BIM. Okay, level 0 BIM basically includes only 2D drawings without any 3D modeling. All your AutoCAD drawings and all your PDF drawings, everything falls under this category of level 0 BIM. Okay, level 1 BIM is a mixture of 2D drawings and 3D models. But here the 3D models does not contain any intelligence, which basically means, for example, your SketchUp model. Architects might know about the SketchUp software. It's a concept design software. So if you select a wall or if you select any object in SketchUp, it will not give you a lot of information. It is good for visualization. Okay, so that is level 1 BIM. Okay, it's a mix of 2D drawings and 3D models which does not contain any intelligence. Level 2 BIM. In level 2 BIM, each project participant, okay, architect, structural engineer, mechanical engineer, electrical engineer, plumbing engineer, all the stakeholders will have their own separate BIM model, and all of them will be an intelligent 3D model. Okay. But in level 2 BIM, we assume that all the stakeholders are using a same software or a similar set of software. Okay. For example, let's say all the stakeholders in the project are using Revit. Okay, Revit. And we are assuming that all the stakeholders are using a particular version. So we assign a particular Revit version to them before itself. Let's say 2021. We say that all the stakeholders should follow that throughout the project. Okay, in that case, it is a level 2 BIM. Okay, and in level 3 BIM, what happens is, irrespective of the software, okay, architect can be using a software called like ArchiCAD. Structural team, steel team can be using a software like Tekla or SDS2. MEP people can be using software like Revit. Okay, all the information contained in the various software or various models can be combined together and create a central BIM model. That is level 3 BIM in a collaborative way. Okay, we call it as collaborative BIM approach. So what happens majorly is, in every project, in any project, there will be an architect, There will be a structural engineer, there will be an MEP consultant, there will be a landscape architect, construction managers, asset owners, right? There will be various stakeholders involved in the project. Okay, in BIM, they all work in the CDE approach. CDE means Common Data Environment. Okay, all the stakeholders work in a common data environment. Basically, what happens is, for example, let's say an architect is moving a wall. Okay, architect is moving a wall 10 inches to the north direction. Okay, mechanical engineer will get to know about the change instantly. Okay, mechanical engineer will get a notification saying that architect has moved this wall 10 inches to the north direction. Similarly, all the other stakeholders will get notification if any of the stakeholder move or make any changes to their model. Okay, so this approach is called as common data environment approach. Okay, this is very important. Next topic that we are going to discuss is super important for you. It's called as level of development or else LOD. Okay, I will tell you why. Let's say for a chair, okay, let's say there is a chair. You don't have to actually show a chair. You can draw a box and show that and name it as chair. That is LOD 100. In LOD 200, it will have some characteristics of a chair. Okay, but in LOD 300, okay, in LOD 300, it will have the right dimensions of a chair. Okay, whatever the chair dimensions of the chair needed to be, it will have the accurate dimensions. Okay, in LOD 400, okay, in LOD 400 means basically it's for fabrication model. Okay, is basically means it will have every information. For example, if there is a roller, roller at the bottom of the chair, it will have that information. Okay, if there is a specific type of handle being used, it will have that information in LOD 400. LOD 500 is as built BIM model. Okay, so as LOD increases, level of information or level of model development increases. Okay, I'll show you more examples. So in LOD 100, it's concept design. Okay, so there are no geometric info in the model. It will be only, for example, for a chair, you can show a box and name it as a chair. In LOD 200 is design development stage of a project. Now the elements are generic, placeholder for elements and equipment to be. Okay, but they are not of accurate size or accurate shape, but they are somewhat similar to a chair. Okay, for example, in place of a chair, you are keeping a stool. Okay, then it is LOD 200. But in LOD 300, it should be a chair. Okay, and it should be dimensionally be accurate. Okay, in LOD 350, what happens is there will be proper cross trade coordination. Okay, between disciplines. For example, architect is creating their model, right? Structural engineer is creating their model. MEP engineers are creating their respective models. In LOD 350, the output model will be coordinated with all other trades. Okay, if I'm saying I am submitting a mechanical LOD 350 model, it means my mechanical LOD 350 model is coordinated with all other stakeholders. It is not creating any issues with other stakeholders. Okay, for that, okay, for me to say, for example, I'm taking the same example of mechanical. Okay, let's say there is a pipe running. Okay, pipe running from south to north direction, a pipe is running. If I have to make sure that pipe is not clashing with anything, okay, I have to add more information to the pipe. Okay, for example, for that pipe, I have to consider the insulation wrapping of that particular pipe. I have to also consider the supports. Okay, how it is going to be supported. It is practically possible for me to support it to the deck slab or not. Okay, then it is LOD 350 model. Clear? In LOD 400 model is a construction model. Okay, this level supports complete detailing, fabrication, and installation of assembly. Okay, so here what happens is I will have the information of each and every component or nut or bolt that is going to be used in the model. I will have to show the details of it. Okay, for example, let's say there is an air conditioner. Okay, there is an air conditioner. Let's say it is Daikin's air conditioner. Okay, it then in my model also, if it's an LOD 400 model also, then it should be a Daikin air conditioner of that particular model number. I have to follow that. I have to follow the dimensions given for that particular air conditioner. I have to follow it correctly. I have to mount. How do I mount it? Okay, all the information will be available in a LOD 400 model. We call it as construction model. Okay, LOD 500 is majorly an as-built model. Okay, as-built model. So what happens here is, for example, let's say you have given a construction model. Okay, you have created a proper construction model. You have given it to the site team. Okay, but during construction by the site team, they made a few changes here and there. Okay, let's say they moved a pipe from your construction model. It was correct. What you have given in the construction model is correct. But due to some site factors, they have to move pipe here and there. They have to move, pipe support, whatever. If they are making such changes on the site, okay, we have to record back those changes to your digital model. That is called as built modeling. So if you record back the changes that is done in the site to your model, it is called as LOD 500 model. You can see it's just a block. Okay, in LOD 200 you are showing the shape but not the color, but not, it is not dimensionally accurate. In LOD 300 it will be dimensionally accurate. In LOD 350 it will have information for coordination, so supports are needed. But in LOD 400 you can see more information like nut, bolt, how it is going to be fabricated, all that information will be provided. LOD 500 is as built. Okay, so let's divide the BIM tools into two categories. Okay, one is BIM authoring tools and second one is BIM non-authoring tools. So BIM authoring tools are the tools where you're actually doing the work. Into, based off its use, you can classify it into BIM execution planning software, content management software, modeling software, generative design software like Dynamo, analysis software, BIM collaboration software like BIM 360, BIM validation softwares are there, pre-construction software, BIM 4D, 5D software like Bexel, facility management software. So type of BIM tool can be further divided based on the purpose of usage on BIM. Okay. So, so BIM authoring tools are the tools to create the actual model. So what are the capabilities of any BIM authoring tool? It will have a user interface. Okay, all BIM authoring tool will have a user interface. It will have the capability to generate drawings. It will have the capability to develop custom parametric objects. Okay, what is custom parametric objects? Okay, for example, let's say there is a table. Okay, and the size of the table, let's say, is length is 6 feet, width is 3 feet. Okay, well, let's say if I'm creating that table in my authoring software, I have to make sure that it is parametric, which means if I enter a value for length, the length of the table should change. If I enter 7 feet, the length of the table should be 7 feet then. If I give a value somewhere for width, the width of the table should reduce or increase accordingly. The model should have that capability, okay, to control the visual appearance of the object by written parameters. Okay, that is called as ease of developing custom parametric objects. Scalability, and then this is very important, interoperability. Okay, interoperability. So interoperability basically means, for example, let's say architect is using a software called as ArchiCAD. Okay, steel team is using a software called as Tekla, and let's say I am with the MEP consultant. That information, any software. I hope you all have used interoperability. Clear, everyone? Just clear, all of you?
Yes. Yes.
Yes, sir.
Okay. And next capability of an authoring tool is complex curved surface modeling. You will be able to create curved surface modeling in any authoring tool. Multi-user environment, which is the Autodesk software. Bentley system have a software called as EcoSim. ArchiCAD is a software. Then Digital Project is there. Tekla Structures is there, and there are other softwares also. SGS2 is there. So there are a lot of software BIM authoring tools based on the purpose, based on the requirement. There are various authoring tools available in the industry. Okay. What is a non-authoring tool? As I've already mentioned, non-authoring tools are majorly model viewers and BIM coordination tools. Those are just used for viewing purpose. You don't require any license for that. Okay, you are not doing any actual work on it. You are seeing it. You can comment on it. Okay, looking at that model, you can comment and you can say this is not looking good. Okay, change the color of the wall. Okay, that you can do in a non-authoring tool. Okay, for that you don't really need a license because you are not creating the wall there. You are just commenting on the wall. Okay, such tools are BIM non-authoring tools. Is this clear, everyone?
Yes.
Yes, sir.
Yes.
Any questions, any doubts, anybody?